All right, we just saw how we can find the exact area underneath the curve. Instead of using a whole bunch of infinite amount of rectangles, we can actually just integrate from a to b. So what that really means is we can take the antiderivative, we can find our original function, we're going to call that big F, and just find the difference, the change from a to b. And so finding the area underneath the curve, integrating from a to b, is really finding the total change in the original function, big F, from a to b. Let me show you an example of what I mean. Example number 3 says, a driver traveling on a business trip checks the speedometer each hour. The table shows the driver's velocity, so his speed, at several times. Approximate the total distance traveled during the 3-hour period using left endpoints for each interval, then right endpoints. So we're going to do 2 different ways. So if all we're given is the velocity, the speed, how can we go backwards and find the distance? Well, if you think about those 2 functions, we know that velocity is the derivative of position or distance, right? And so if we're given the velocity, the derivative, how can we go backwards and figure out what the distance is that he traveled over the 3-hour time period? Well, what we can do is integrate. We can take our velocity function, we can integrate it from 0 to 3 over the first 3 hours, and that'll tell us the distance that he traveled over those 3 hours. The problem is we don't quite know how to do this yet. We do know how to find an antiderivative or integrate, but we don't know what to do with the 0 and the 3 yet. We'll learn about that in the next section. So the only way that we could actually do this is by still approximating using our rectangles. We're going to do left endpoints first, and then we're going to do right endpoints. And I don't know about you, but it's easiest for me to graph what this looks like so I can have a visual of not only what my velocity graph looks like, but what my rectangles look like. So I know if my answer is going to be an overestimate or an underestimate. So I'm going to take the data from my chart and I'm going to graph it. It's going to be a sloppy graph, but I'm going to graph it just so I have a rough sketch of what it looks like. So I know at 0, my velocity is 0. I know that at 1 hour, my velocity is 52 miles per hour. I know that at 2 hours it was at 58, so a little bit more. And then I know at 3 hours it was 60, so a little bit more. So my curve kind of goes up slowly like that. This is the graph of my velocity, remember. We can use it, though, to find the distance, working backward. If I want to figure out what my antiderivative is, we know that's really the same thing as the area underneath the curve. I'm going to use left endpoints first. So it looks like I have a 3-hour time interval. So I'm going to do 1, 2, 3 different rectangles. Base times height, plus base times height, plus base times height. If I have a 3-hour time interval and I want 3 different rectangles, well then I know that each rectangle is going to have a base of 1 unit. But now I need to find the heights of these rectangles. If I'm using the left endpoint, then I'm going to follow it up from the left. Oops, I didn't want to erase it. Here we go. Follow it up from the left and go over. Follow it up from the left and go over. Follow it up from the left and go over. You might notice that my rectangles are all below my curve, so this is going to be an underestimate. I need to find the heights of each of these rectangles. I know that the height of the first rectangle was 0. That's when x was 0. The height of my second rectangle was this y value when x was 1. My height of my third rectangle was when x was 2. So let's use the chart since I don't have an actual equation to plug 0, 1, and 2 into, but I can use the chart. I know that when x or t, whatever my variable is 0, that my velocity is 0. I know that when t or x is 1, my velocity is 52. And when t is 2, I know my velocity is 58. So those are the heights of my 3 different rectangles. My height is 1. My base is 1, my height was 0. My base was 1, my height was 52. My base was 1, my height was 58. You might notice that I also put in here labels. If I'm looking at this chart and I'm looking at 0 to 1, isn't that really a time in hours? So if I'm looking at putting labels on these numbers, this is really 1 hour. And when I put a 0, what did that 0 really represent? Well, that 0, when I plugged in 0 and got out an output, a y value, that was really how fast I was going in miles per hour. So if I'd go down here and put my units, do you notice I put 0 miles per hour? So then I had my 1 hour and I went 52 miles per hour. Then I have my 1 hour and I went 58 miles per hour. So you notice that I have my units in here because that's going to help me figure out what my answer really means. And you might notice that this 1 hour in the numerator and the hour in the denominator cancel. The hour in the numerator, the hour in the denominator cancel. And so all I'm left with is miles, right? And so if I multiply base times height, base times height, base times height, and add them together, I ended up getting 110. So what that really meant, what that really means about my situation, is I actually used the velocity to work backwards and figure out my distance. So distance is really in miles. I went approximately 110 total miles in those 3 hours. Remember, this was an underestimate though, because my rectangles were below. So what if I used right endpoints? And let's see and approximate my distance traveled over the 3-hour period, but all I have is velocity. I can do the same thing using my velocity graph to find the area underneath the curve. We know that the area underneath the curve of velocity is really the antiderivative, which is position or distance. So I can find the total distance from 0 to 3 by really finding the area underneath the curve of velocity from 0 to 3, right? Or the antiderivative. Let's use right endpoints of our rectangles now. I'm still going from 0 to 3, and I'm still going to use 3 rectangles unless they say I needed to use more or less. I just chose 3 because that was a nice even number with the intervals that they gave me. If I'm using right endpoints, going up from the right, my rectangle would be here. Going up from the right, my rectangle would be here. Oops, I don't know what just happened. Oh no, what's happening here? It's freaking out. Okay, let's try that again. Up from the right, my rectangle's here. Up from the right, my rectangle's here. Up from the right, my rectangle's here. You might notice now that if I'm using right endpoints, my rectangles are above the curve. So when I find my answer, my distance is going to be an overestimate. So we can kind of pick something in between my underestimate and overestimate. My bases are still both going to be, are all going to be 1, right? And so 1 would be the base of all my rectangles. Now I need to find the heights. What x value corresponds to the y value or the height of my first rectangle? Well, if my height was here, it looks like that's x equals or t equals 1. What x value corresponds to the height of my second rectangle? Well, it looks like that's an x value of 2. And then my last one would correspond to when x is 3. So using my chart again, let's figure out what my velocity was at 1, what my velocity is at 2, and what my velocity is at 3. I ended up getting 52, 58, and 60, making sure that I'm only using 3 rectangles, right? When I add those together and multiply by 1, I ended up getting 170. Remember, if this is the area underneath the curve of velocity, I'm really finding the antiderivative, which means I'm really finding the position. And my units for position or distance, in this case, would be miles. So this is saying that over that 3-hour time period, I went approximately 170 miles total. But we know that that's too much, right? So 110 was too little, 170 was too much. So I went somewhere in between, maybe 130 or something. But I'm only using it to estimate my distance because all I have is the velocity. In order to find the exact distance, I would actually have to integrate and evaluate from 0 to 3. I'll show you how to do that in the next section so we can actually find the exact distance traveled instead of just estimating by using rectangles. Now, it's really important that you understand the meaning of these answers. So I've quickly just kind of jotted down a few examples. Let's say I asked you to integrate marginal cost, and I have a 0 and a 5 here. I'm asking you to integrate marginal cost from 0 to 5. Well, remember, marginal cost is the same as the derivative of cost, the rate at which the cost was changing. If you're integrating the marginal cost, what does your answer really mean? Well, if you're going backwards and you're doing the antiderivative or the integral of marginal cost, doesn't that mean you're actually just finding the cost? But because I have a 0 to 5, what I'm really doing is I'm finding the total change in cost from 0 to 5. So 0 to 5 years, 0 to 5 days, whatever your units are. we're really finding the total change in the cost from 0 to 5. I can integrate to find the original function from 0 to 5. So then what would your answer mean if you were integrating the marginal profit from 1 to 7? Remember, marginal profit is really the derivative of profit. So if you're integrating, you're finding the antiderivative, which is really the actual profit. But it's the profit change from 1 to 7. So you're finding the total change in profit from 1 to 7. So being able to do the problems is important, but really being able to interpret what they mean is the most important. What does the answer mean when you actually integrate from 1 to 7, or integrate from 0 to 5, or integrate the velocity from 0 to 3? Well, if you're integrating the velocity from 0 to 3, you're really finding the total change in your distance from 0 to 3. You're finding the antiderivative from 0 to 3. All right? So make sure you can actually understand those ideas between the area underneath the curve and integration and what the answers actually mean. Can you interpret the meaning?